In this lesson, we're going to talk now about how to add modules to a task. We've just seen how to create a dynamics process, which contains tasks, then set up tasks that run at different frequencies. So it's time for these tasks to actually do some work. In particular, we're going to cover two types of modules. There's a C module and a C++ module that we want to add. So we can show the subtle differences between the two. So let's jump right into the code. We're going to use our generic C module template and C++ module template modules. These get auto-created when you create Basilisk. And so there's some nice generic Lego blocks we can use to connect together and play with it. Looking at the rest of the code, you can see we're creating our simulation first, which is our Basilisk simulation. We're creating a process. We're creating a task, as you've earlier done. So now the next steps are we need to create these modules, add them to a task, and if needed, specify the order in which these modules should be executed. This will sound very similar to how we had orders of processes being executed or orders of tasks being executed. The first one we're going to do is a C module. And you notice here a change from how it was done earlier. In earlier versions of Basilisk, I am running a beta version here actually of 2.2.1. This is where we've introduced some nice modification to Basilisk, where C modules can be created just like C++ modules. If you're looking for instructions on how to set up the earlier version of C modules, where it was a three lines instead of 2 lines, you can go look at this file down here, depreciated using old style C modules. But this is now legacy, depreciated, and within a year, we're going to remove that functionality completely. So all the existing code should run for now, which is great. So how do we make a C module? Well, you've included your module up here with the import statement. Next thing you do is now we simply have the module that we included, that's the name. And then inside that module, you repeat that name with the closing brackets, same spelling. And this will create for you automatically a Basilisk module where you're running internally C code. If you're curious, in the innards of this function, we actually have to create a copy of a structure that contains all the module variables and then assign that structure and wrap it in a C++ one so we can execute with the rest of the code. So the things we used to do in the old way still happen, but they all happen now magically under the hood. So as a new user who never might see the older ways, this is great. Way to go. So what we do is we create a copy of that module. So now we have a unique module. I'm just calling it mod1. And if you look here, we're trying to have module 1 first actually execute module 2, then 3, then 1. So we're intentionally making the third module first, just so we can set priorities. Every module should have a model tag. This is basically a unique string identifier. So in the code, if you ever want to call who are you, you just do, show me your model tag, and it will be your identifier. So very uncreatively, I'm just calling it C module 1, and that's it. Now we've created a Basilisk module. It won't be executed. We haven't added it to a task, but we've at least created it. We're going to make the next 2 modules. The second one is a C++ one, and so we import it here from your library, the Basilisk CPP module template. And then we have to include the class name. So these modules are based on C++ and have class names. Class names always start with a capital letter. So just be aware of the subtle spelling differences that might exist. Whereas C modules aren't classes, and you might find some with or without a capital letter. You just have to go look at the documentation or look at the code to get the proper name that you can invoke. But it's the same 2-line process. So that's part of Basilisk 2.2.1. You no longer have to distinguish, are you working with a C module or C++? You can treat both the same, which is a beautiful simplification. Lastly, we make another C module. So we repeat the process. We're just calling it mod3, some unique identifier, give it a unique string, and that's it. So after these lines of code, we've created the 3 modules that you see illustrated up here. Now the next task is we need to add them to the tasks. And just like with setting up tasks and setting up processes, unless you give a priority, these modules will be executed first added, first executed. So if you add module 1 first without a priority, it would get executed first. Then we add module 2, and now there's an optional priority. And just like with processes and tasks, the higher the priority number, the earlier they'll be executed. So if I didn't have priorities, I would have module 1, 2, and 3 executed in that order. But up here, we said we wanted module 2, then 3, then 1. So I can do that as illustrated here. I'm adding module 1, but no priority. So as soon as I add a module, here module 2, with the priority 10, it will be executed before module 1. And then I add finally module 3 with priority 5. It will be executed ahead of any module without a priority, but obviously after one with priority 10. So now we've added the 3. The final step is we call initialized simulation. And what this does is this will actually make sure every module gets properly initialized, and we call reset on every module, so everything gets configured to default behaviors that this module should have. And then we configure a simulation time, so we configure a stop time of 5 seconds, and then execute the simulation, and this will run for 5 seconds. And you can see below the output that you should have. So this goes through some stuff, and you can see the dummy output that we have. So that's all explained here as well. So that's the task. Basically, we have just 2 lines now as of Basilisk 221 to create Basilisk modules. You configure them and set them up. And so the next lessons will talk about how to configure variables in modules, how to record output messages, connect messages in modules. Right now, we just have default behavior. We created them, we added them, we execute, but we don't set gains, we don't set variables, we're not connecting any messages yet. So we started to create a simulation, but we're not really there yet at a fully fledged functional simulation. That'll be next.